Now let's take our next question, that is question number 19. Here is the question. This belongs to section of electromagnetism from chapter current electricity. As per the question, there's a figure given to us and we have to find the current which is being drawn from the battery, right? And various value of resistors is given. So let's take this as I. Here R1 is given as 15 ohm, right? This R3 is given as 20 ohm. R4 is given as 5 ohm. R5 is given as 25 ohm. R2 is given as 10 ohm and R6 is given as 30. Now this can be solved to an equivalent. This 25, that is series, it will become 50, and 50 and 10 will be in parallel, right? When 50 and 10 are in parallel, the equivalent resistance for them will be, let's say this, and this value would be simply 50 into 10 by 60. So that would be R dash for me, and this is simply 50 by 6 or 25 by 3, right? So I have one resistor 25 by 3 ohm, the other one is 15 ohm, and the one which is downwards is 30, right? And the value of E which is given is 15 volts. So here is the cell which is having 15 volt, right? So when you solve this, it's easy to find the net internal resistance here. So solution, R net to be written as, they all are in series, so it is 15 plus 25 by 3 plus 30, and current I will be equal to E by R net. When you solve this, you will get 9 by 32, that is 15 by the net resistance, and which is the best suited option here? Among the four, option number 2 is the right answer. Correct? Let's move on to our next question. Now, the question you see, it belongs to mechanics from the topic of vectors, that is vector addition. Here there are two vectors, the magnitudes A1, A2 is given as 3 and 5 respectively, where the resultant A1 plus A2, the magnitude is 5, then the value of this particular combination we have to find. So let's start with the solution. If you solve it complete step by step, it will be a very lengthy solution. So there's a trick hidden here. If you see the magnitude, this portion, so resultant of A1 plus A2 is 5, so R square can be written as A1 square plus A2 square plus 2A1 A2 cos of theta, right? Now if I simplify this, I'll rewrite this equation as A2 square plus 2A1 vector dot A2 vector, because A1 A2 cos theta can be written like this. Now these are the magnitude, this has been represented in vector form. Now just put down the values. So this is 5 square, that is equals to 3 square, plus this is equals to 5 square plus 2 times of A1 dot A2. When you solve this, this is 25, this is 9, this is 25, you will get minus 9 by 2 as A1 vector dot A2 vector. Let's take this as first equation, right? This would be the first equation we have derived. Now let's talk about the second part. For the given expression of 2A1 plus 3A2, this has to be dot product with 3A1 minus 2A2. So let's write it, 2A1 plus 3A2 dot product 3A1 minus 2A2. This is the expression we are going to solve, and we need to simplify this one, right? Let's match it here. So that would be twice of A1 plus 3 thrice of A2 and 3A1 minus 2A2. Now let's open the brackets for instance. So 2 into 3, that would be 6 into magnitude of A1 square plus 5 A1 dot A2 minus 6 mod of A2 square. Now this is 6, the value of this is 3 plus 5 into minus 9 by 2, because this A1 dot A2 is given here, right? And then minus 6 into this is 5 square. When you solve this, you will get minus of 118.5. Let's see which is the best suited option. So among the 4 options given here, yes, option number 2 would be the right answer. I hope you have understood this one. Now let's take a next question. Now the question you see here belongs to optics. Here, calculate the limit of resolution of a telescope objective having diameter of 200 centimeter and it has to detect light of wavelength 500 nanometer. Now it's a very simple formula based question where the limit of resolution will be given by 1.22 lambda by diameter. So that would be 1.22 into 500 nanometers, that is 10 to power minus 9, and the diameter is 200 centimeters. Simply I can write it as 2. On solving you will get 305 into 10 to power minus 9 radians. So option number 2 would be the right answer to this question. I hope you have understood this one. Now let's move on to our next question.